For number 8, we have the limit of an plus bxn minus 1, and when x approaching to infinity, we can say that limit is equivalent to the largest degree of polynomials here for x, because when we have this term, we can get factor from x with the largest degree, and if we suppose that xn has the largest degree when n is natural number, so we will have limit of xn power an plus an minus 1. This one will be divided by x to get xn, so x plus another sentence also, for example, another one is an minus 2, xn minus 2 will be divided by x2 and continue. When x approaching to infinity, so all of this number, because is number over infinity will be 0. So we will have just x and an. That's why it's only depend on an and n to get the limit when x approach to infinity. And for number 9, the limit of these polynomials when x approaching to infinity, we have tried here this dividing the top and bottom by the highest power in denominator. So I want to use this one, and the number 10 also will be the conclusion of number 9, that you can directly use number 10. Let's start with some example and see how we can use number 8 and 9 and 10. For the polynomial number 8, 9 and 10, I have considered these 3 examples. When we have this limit, if I want to, without using that number 10 directly formula, if I wanted to solve, so I have to get the factorize from the largest degree of x. So here I have to get from the x2, and here also x2. So it will be equal to limit of x2 5 plus radical of here x2 I got factorized, so it's coming inside, it will be x4. So I will get 7 over x4 because x2 over x4, so I will get x2 minus x over x4, so I will get 1 over x3 over here also from the x2 I will factorize minus 1 over x2. So when x approaching to minus infinity, it will be equal to here 7 over infinity will be 0, 1 over infinity also 0, so I will have 5x2 here, and 5x2 here, 1 over infinity is 0, so here 0, 0, so I have 5x2 over 2x2, that x2 and x2 also will go on, I will get 5 over 2. Even if I was using this direct formula here, if m and n, the degree of denominator and numerator be equal, so it is just the ratio of coefficients together. So here I just, if I wanted to use the number 10 as the largest degree is 2, just I should divide the coefficients of x2 together, so just 5 over 2. And so another one is this. I just, if I wanted to use the number 10 as the largest degree is 2, just I should divide the coefficients of x2 together, so just 5 over 2. And so another one is this one. If I wanted to factorize and using number 8 or number 9 track, just from here the largest degree for x is x100 here, and the largest degree here is x 125, so I can rewrite as here I have 1 plus 10 over x 99 because 1 it will be decreased, and minus 3 here x 100. If I divide, I will get, here it's coming down, I will get x e minus 100. And also from here I will get 1 over x, here is minus 1, so together 124 minus 6 plus 1 over x 125. So here number over infinity is 0, here also 0, this one also number over infinity is 0, number over infinity is 0, so I will reach to this limit when it's approaching to positive infinity. Here is 1 over minus 6 times x 125. So here if I decrease the 100 from 125, so I have 25 degree here and number over infinity, so the limit equal to 1 over minus 6 x 25, which is equal to 0 when it's approaching to infinity. So even I could directly use, and here I see the largest degree is 100, and in the denominator the largest degree here is 125. So as according to the number 10 strategy, here in the denominator degree is more, so I will get 0. So the last one is this limit. If I want get the largest degree, here consider is x3, so I will factorize from x3, I will reach to 1 plus 10 radical x over x3 minus 3 e minus e x over x3 divided by, here the largest degree is here is 5 over 7, here is e, that is approximately 2.7, so it's x e, here is x 5 over 7 over x e minus 6 plus 1 over x e when x approaching to positive infinity. So if I use here the degree here 3 minus 1 over 2, because here the degree is 1 over 2 and it's coming down, so I have 3 minus 1 over 2, which is equal to 5 over 2, and here we have 10 over infinity, it will be 0. So also here 3 0 0 here will be deleted, and also here 5 over 7 here e, and e minus 5 over 7, so I have 1 over e power e minus 5 over 7, that will be 0 again, and this one also 1 over infinity 0, so I will reach to x3 in numerator over minus 6 x e, and these key limits when x approaching to infinity. Here the degree of this one is more than e because we will have 3 minus e, so this limit is x 3 minus e when x approaching to infinity will be infinity, and this is positive infinity time in the coefficient that is negative, so we will reach to minus infinity. If I wanted to use the number 10, I have to divide the largest degree in numerator over the largest degree in denominator. So here as the largest degree in numerator is x3 and in denominator is xe, so it should be infinity, but depend on the an and bn. Let's come back to this. As you see here, x3 is more than xe, so it should be infinity, but the coefficient x3 is 1, coefficient is xe is minus 6, so the result should be minus infinity. Now let's come to this example which before in section 2 in topic of Hopital I have promised to solve. We have here limit of x minus 2 over x plus 3 power x over 2 when x approaching to infinity. First of all, we substitute infinity according to ratio function. This ratio has the limit of 1 x minus 2 over x plus 3 because denominator and numerator have same degree 1, so the coefficient divided by 1 we will get 1 power infinity. To solve this question, as I have over here, we can suppose this equal to y, and we can get ln over from both sides, or even use the exponential ln e fx, which is always equal to x. So exponential of ln y equal to limits of exponential ln of x minus 2 over x plus 3 power x over 2 when x approaching to infinity. So here x over 2 can come here, and even the limits come inside. So I can write limit of exponential, sorry, it is coming here, so I will write exponential of x over 2 ln x minus 2 over x plus 3. So when it's approaching to infinity, for result we can write here exponential of ln of x minus 2 over x plus 3 over a 2 over x. Now when x approaching to infinity, limit can come inside, so I can write exponential of this limit ln x minus 2 over x plus 3 over 2 over x when x approaching to infinity. If I put infinity here 0, if I put here infinity, I have ln of 1 that is equal to 0, so I have 0 over 0. Now I can use the Hopital rule here, so I can get the derivative from numerator and denominator, and derivative of this one will be equal to x plus 3 power 2 derivative of x1 times x plus 3 minus derivative of this one multiply in x minus 2, so I will get minus x plus 2. Derivative of ln u is equal to u prime over u, so we will have this as a u prime over u, which is x minus 2 over x plus 3, x minus 2 over x plus 3 over derivative of 2 over x, which is minus 2 over x2 will be this equal to, now we can delete x, and in after simplification we have exponential of 5 over x plus 3 power 2 over x minus 2 over x plus 3 is coming down time minus 2 over x2. Limit can get when x approach to infinity, and after simplification x2 coming off, and we will delete x plus 3 in both denominators, so we will have exponential of minus 5x2 over 2 times x minus 2 times x plus 3. When x approaches to infinity, so according to ratio function limit, the largest degree is x2, so limit exponential of limits of minus 5x2 over 2x2, and we will delete x2, we will get exponential of minus 5 over 2. Thank you for your attention. Hope this section be useful for you, and please continue the next section in following video.